Aiden, what's up, my boy? Hope you enjoy watching this.
All right, so
Think you can hear me?
we did almost forget to record. Okay, so all we've done so far, let me recap, is we took the function and we distributed, and we got that, and then we rewrote it in descending order. Now we're going to take the derivative. So that would be 5x to the 4
plus 3x squared
plus
6x.
3x squared plus 6x plus,
Nothing.
0. Okay, so there's our derivative. Okay, now I'm going to explain to you what this product rule is, and I'll use the product rule to find the same derivative and show you that we'll get the same result. Okay, so product rule is when we have two functions of x that are being multiplied. In the rule, we're going to call the first function u and the second one v. And the rule is u prime times v plus u times v prime. Okay, so when I write out this equation again, f of x, I put y, same thing. I have x squared plus 1 times x cubed plus 3. This will be what I call u, and this will be what I call v. So it's a function of x times another function of x. That's when we use the product rule. Okay, so this is what the product rule says, that the derivative will be u prime. Okay, well, what's the derivative of u?
X.
2x
2x.
times v times x cubed plus 3 plus u, which is x squared plus 1, times v prime, the derivative of v is 3x squared. Okay, so I'm going to write below or above these. This was u prime times v plus u times v prime. So that's how we applied the rule. Now from here, I'm going to multiply, distribute, and see if I have any like terms to add up. Okay, so that's 2x to the 4 plus 6x plus 3x to the 4 plus 3x squared. And looking for like terms, I have 2x to the 4, 3x to the 4 is 5x to the 4. Then I have a 3x squared. And then I have a 6x. And you can see that we did get the same thing as we got over there to the left.
Yeah, it seems easier.
Okay. Yeah, so which one do you think is easier?
First
Okay.
one.
And that's perfectly fine. When you have a problem like this, you choose how you solve it. There will be some functions where we have to use the product rule. This is not one of them. So if it's something that you say, well, you know, I could just distribute that, then go that route. That's fine. Okay? But eventually we'll encounter some where we don't want to distribute and the product rule will be easier. Yes?
When is eventually?
In the not too far future.
When
tomorrow?
they quiz, can we just do the, like, can we just distribute?
Yeah, I don't think we'll have any then, by then, that will necessitate the product rule. I was going to say something else. Oh, okay, what if I did this first? What if I did uv prime first plus u prime v? It's the same, because addition and multiplication are commutative. Doesn't matter what order you do those in, right? So sometimes when I set it up, I will start out with the uv prime. I just sort of flip-flop and do both. So it doesn't matter what order those are in. Okay. No, it's not. Okay, so for the quotient rule, I didn't put one on here where we don't have to use the quotient rule, so let's look at one. If you want to add this to the last piece of paper, we can do that back piece. Let's do this. So, before we look at the quotient rule, I'm going to do one where we don't have to use it and show you that we will get the same thing with the rule. Okay, so I'm going to put this as example. We'll call it 4.5 because it's between 4 and 5. All right, so we're going to find the derivative. F of x is 3x cubed minus 9x to the 4 plus 18x over 3x. Okay, so one thing that I can do is just take each of these terms and divide it by 3x. So that's what I'm going to do first. Not taking a derivative, I am just dividing all 3 terms in the numerator by the term in the denominator. So 3x cubed divided by 3x is, okay, go on, do the next one. Minus 3x cubed. Is that what you said, John? Okay, 18x divided by 3x plus 6. All right, just for the fun of it, let's rearrange. Okay, now I'm going to take the derivative. Negative 9x squared plus 2x. Okay, so ta-da, we did it.
Yeah.
Now I'm going to do the same thing using the quotient rule. Okay, let's look back and I want you to see what this crazy quotient rule looks like. Okay, so what I am taking a derivative of is a function that is a quotient, a fraction, division. And I'm calling this u over v. Okay, here's how we find the derivative with the quotient rule. It is v u prime minus uv prime over v squared. Okay, once upon a time I taught out of a textbook that used this little rhyme that I really like because that helps it stick in your head. So I like to use it. Here's the rhyme. Low d high minus high d low over the square of what's below. Okay, so let's see how that interprets. Low is the denominator, v. D high means derivative of what's on top. Derivative of u prime. Minus high, what's on top is u. D low means derivative of what's on bottom, so that's v prime. Over, there's your fraction line, the square of what's below. What's on the bottom is v, and if we square it, we get v squared. So low d high minus high d low over the square of what's below. Okay, all right, so let's write this out. F of x is u over v. F prime of x is, I'm going to say the rhyme, low d high minus high d low over the square of what's below. Okay, so let's put that into practice here with the original function that I had up here. Okay, so f prime of x is low. D high, take the derivative of just the top, 9x squared minus 36x cubed plus 18.
Wait.
So this is low, u prime is d high.
Why is there 9x minus 3x.
Derivative of the top would be 9x squared minus 36x cubed plus 18.
Okay.
So all of that is what I'm calling u prime.
What's the V and what's the U again?
V is on the bottom, u is on top.
Okay.
So it's this over this.
Okay.
Okay? All right, so that's VU prime minus U and then V prime.
3x
U is
squared.
the top, all that stuff. And then V prime is just 3. So this is U, V prime. All over
9x squared.
bottom square. Okay, we got some distributing to do. Okay, 27x cubed. Ooh, what's 3 times 36?
8.
108. X to the 4. 18 times 3? 54. Okay, minus 9x cubed plus 27x to the 4 minus 54x.
Wouldn't it be
Why is it plus 27?
Okay, can anybody answer that?
Oh, okay.
Because I have, if it helps, move this 3 up here. So negative 3 times 3, then negative 3 times negative 9 becomes plus 27. Oh, Lordy. Okay. Let's see. Negative 108 plus 27. Anybody? Negative 81, x to the 4. Okay, here's some cubes. I have 27 minus 9, 18, x cubed. No x squares, 54x is canceled. Over 9x squared.
prime of x?
Now, everything up top divides by 9x squared. So when I do so, I get negative 9x squared plus 2x.
The other way was far easier.
Same thing we got above. Okay, I agree, it was easier. But there will be times when we have to use the quotient rule. Okay, but if it's a situation like this, then take your pick, do it either way. All right?
So how do you know if you make it use the rule?
Okay, we'll do one in right here, this next one. Okay, so for this next one, we're going to use the quotient rule. Okay, so what does differentiate mean? Find the derivative. What does derivative mean?
Slope of the original function.
Slope of the function, slope of the tangent, instantaneous change at a particular point. Okay, so can I reduce this fraction?
Yes. No. Yes, actually.
Okay. All right, I'll agree. That's the difference of 2 squares on the top would factor into plus 1x minus 1. Okay, does the bottom factor?
No.
It's a sum of 2 squares. Does it factor? If you did try to factor, what would you use? X plus 1, x plus 1. Okay, but think if we FOILed out x plus 1, we'd get a 2x in the middle, wouldn't we?
Yep.
Okay, sum of 2 squares will never factor, even though it looks like it should. Difference of 2 squares we can factor all day long with those conjugate factors. X plus 1, x minus 1. Sum doesn't factor. Okay, so factoring isn't an option. Can I cancel out x squares?
No.
No.
Be able to.
It looks like we could, but we can't. Can I factor an x squared out of the numerator? No. We can only cancel common factors, not terms. X squared are terms here. Can't cancel common terms.
What makes them a term?
That they're added or subtracted.
So if it was
Factors are things that are
so
multiplied.
if it was like 2x squared over 2x squared.
Yeah, then I have common factors of 2 and x squared there.
Okay, what if it was like 5x squared over 3x squared?
Then I only have common factors of x squared, and those would reduce.
Okay, so then it would be like 5 over 4.
Mhm. Mhm. But if I put a +1 or a plus anything after one of those, then can't factor it, can't simplify it. I know, they mess things up. Okay, so here's a situation where I can't simplify, so I have to use the quotient rule. Okay? All right, so here we go. Do you know the rhyme?
No, but
Low D high minus high D low over the square of what's below. Okay, so here we go. Uh-huh. All right, low. That means what's on bottom. D high means derivative up top, which is
two x.
2x minus 0, so just 2x. All right, so that's low D high minus high
X squared minus 1,
means what's on top.
and that would just be
D
2x.
low, derivative of what's on the bottom. Over the square of what's below. Now, if what's below is more than one term, put that sucker in parentheses. Okay, now we can clean up the top a little bit. So let's do some distributing there. We're going to get 2x cubed plus 2x. Okay, minus 2x cubed plus 2x.
The 2x3s.
Okay, I am not going to distribute out the denominator. If you want to, then you go for it.
Why aren't you distributing?
Because when I see that numerator, I see some things that are going to cancel. And I'm only going to have a 4x up top. There's no way if I distribute that, there's going to be a factor of 4x. So it's not going to reduce. So I'm just going to leave it as 4x over x squared plus 1 squared. Now, if you want to distribute, that's fine. There's no reason why you shouldn't, but it's also fine to not distribute. Okay. Unless I see that it's going to help me reduce, then I probably would distribute. But it's not going to help me reduce anything, so I'm just going to leave it. Okay. All right, so in this next example, we're dealing with two functions, u and v, but we don't know what those functions are. Mystery functions, but we do have some values, u of 2, u prime of 2, v of 2, and v prime of 2 that are given to us. The 2 is just an x value.
So where x is 2?
Mm-hmm. Yep. So in function u, when x is 2, the y is 3. And the slope is -4. Okay, so we're going to find the product of u times v. All right, well, clearly that's a product. So the derivative needs the product rule. Okay, so I'm going to find y prime, and I'm just applying the product rule. So u prime v plus u v prime. That's our product rule.
Wait, I thought it was minus.
Minus on the fraction one, plus on the product. Okay, well, I want to find y prime of 2. So not only do I want to find the derivative, but I want to find the derivative at a particular point when x is 2. So all that's going to change is this will be y prime at 2 times v at 2 plus u at 2 and v prime at 2. Okay, but even without knowing what u and v functions are, we are given the values that we need up here. So I'm just going to sub them in. So y prime of 2 will equal u prime of 2 is negative 4. V of 2 is 1. U of 2 is 3. And v prime of 2 is 2. Which is negative 4 plus 6 or 2.
Would this also be correct?
Yes, absolutely. Y prime of 2 equals 2. Okay, the next one, negative 2u plus 5v. All right, so first of all, I'm going to just take the derivative of that. Now, negative 2 is a coefficient. The coefficients stay with it, so it's going to be negative 2u prime plus 5v prime. Well, it's at 2, so y prime of 2 will be negative 2 I don't need that extra parentheses. It's okay if I have it, but let's get rid of that. Okay, so, and did I really have to put that of 2 in there? Not necessarily, because I don't have any other options up here other than of 2. Okay, now let's do some substituting. Negative 2. U prime of 2, if I look above, u prime of 2 is negative 4. Plus 5. V prime of 2, look above, v prime of 2 is 2. 8 plus 10 is 18.
So, this is a completely different thing than 5. You didn't use like the same thing.
Right, so on part C, we're going to use what we did in example 5 because it's a quotient.
Okay.
So in part A, I used the product rule because it was u times v.
So but the little rhyme only applies to
The quotient.
quotient.
You got it. Part B is actually like we did yesterday, where you just term by term take the derivative. And now part C is the quotient, so I will use the quotient rule here. So I just kind of have to analyze what I'm dealing with and which rule to use. Okay, so y prime, low, d high.
It doesn't matter what way we put it, like we do u prime times v, right?
Correct, but what does matter is I can't switch the order of these two terms because subtraction isn't commutative. But within the product, I could put u prime first and then v. Multiplication is commutative, but subtraction is not. Okay? Okay, so low d high minus high d low over square what's below. Okay, I don't think I'm going to put the of 2 on these because 2's our only option to use here. So I'm going to go up and find v of 2 is 1. U prime of 2 is negative 4.
Wait, why is it v1?
Because I find v of 2. Minus u of 2, then v prime of 2 over v, which is 1 squared. Okay, negative 4 minus 6 over 1 is negative 10.
Okay.
Question?
Are we gonna have to memorize all the different rules?
Yes. Yep. Well, you will use them so much, it'll just become second nature. I know it seems weird right now, but it'll become second nature.
Wait, we're doing 7 too?
Okay, yep, last example. We already did example 8 yesterday, correct? Okay. Where we kept finding the derivative of the derivative. Okay, so example 7. Find an equation for the line tangent to the curve y equals x squared plus 3 over 2x at the point 1, 2. Support your answer. Graphically, we could use the quotient rule or split the one fraction into 2 and use the power rule. Which one would be easier? What do we need in order to write the equation of the tangent line? Okay, let's first of all look at the graph of this thing and kind of see what it is we're finding. Not totally sure what that graph looks like, so let's graph it and see. I think I already have it in here. I do. Okay, kind of looks like a hyperbola, but we've got this, it actually has a slant asymptote here. Can you see what I'm talking about? See that diagonal line that kind of cuts through it? This is approaching infinity as x approaches infinity, and this is going to negative infinity. So the end behavior is like the line, 1/2 x, and I'm getting 1/2 x from reducing the highest degree over the highest degree term. So that's why the end behavior is linear in fashion. But what is this break in the graph created by? Vertical asymptote at 0, because I cannot use x equals 0 in the function. That's where the vertical asymptote is coming from. Okay, so I'm interested in the point 1, 2. So that's somewhere right in there on my graph. So if I were to sketch this on paper, let's see if we can do it justice. Something like that. And I'm interested in the point 1, 2, which looks like it might be somewhere around in there. And I want to find the equation of that tangent line. So that's what I'm looking for in the problem. Find an equation for the line tangent to the curve at the point 1, 2. So that's just sort of a visual of what I'm expecting. Okay, look at this. Would you want to divide everything up top by 2x and then do the derivative? Or would you rather use the quotient rule? I think I would use the quotient rule here only because 3 over 2x is 3/2 x to the negative 1, and that might get a little messy. So I'm going to use quotient rule on this one. So let's find our derivative. Then we'll worry about at the point 1, 2. Okay, so y prime, low, d high, minus high, d low, over
2x squared.
Square of what's below. Okay, now notice anytime you have more than one term, make sure you put that in parentheses. And I had 2 things here. It's not 2 terms, it's just 1 term. But the 2 and the x get squared, not just the x. So be sure to think of parentheses there as well. Okay, let's simplify. 4x squared minus 2x squared minus 6 over 4x squared. Make sure you're okay with all that. Okay. Can I cancel the 4x squares?
No.
No, because I can't factor out a 4x squared from the top. I can simplify. This is 2x squared minus 6 over 4x squared. Now, I could reduce everything by 2. I'm just going to leave it. Because what I need to do next is sub in the x value. I'm interested in the slope at this point 1, 2.
Wait, where did the 4x squared go on the top?
I combine these two like terms.
Oh,
and change that to 2x squared. This serves as a formula to find the slope anywhere on the curve. I'm interested in this point. At this point, x is 1. So I'm going to evaluate the derivative at 1. So I'm going to find y prime of 1.
Equal to.
Now,
1
anywhere there's an
squared.
x, right, we're going to sub in the 1.
It's just going to be 2 minus 6 over 4.
2 minus 6 over 4 times 1. So negative 4 over 4 is
Negative 1.
negative 1. What does that represent? The slope. Here is the slope of our line.
I mean,
Okay.
why?
To write the equation of that line, what two things do I need?
A point and
A point and the slope. I have a
minus
point
2
and I have the slope. So now we can write the equation.
x minus 1.
Y minus 2 equals negative 1, or just negative if you want to, x minus 1. Leave it that way, or change it to slope-intercept form. So either way is perfectly fine. Question. What if they did not give us the 2, the y value?
We have to plug it into the original equation.
Plug the x into the original function. So you plug x into the derivative to find the slope, plug x into the original function to find the y coordinate that goes with it.
Okay.
Abby?
This one, for the first, part of the first question,
Mm-hmm.
did we use the quotient rule or the...
We end up using the quotient rule. Mm-hmm. Yes.
Would it have been easier to do the quotient rule because we didn't want to find the derivative of the fractions or negative?
Yes. So if we had not used the quotient rule on this one, I would have to break this up into x squared over 2x plus 3 over 2x, which would become x over 2, and that wouldn't reduce there. So what I would then change it to is 1/2 x plus 3 halves x to the negative 1. And that seems a little messier to me than using the quotient rule. But you could do it, and you get the same answer in the end. Yes. Jonah?
Would it be plus 3 and not minus 1 in the final equation?
Yes, thank you. Yes, make that correction, y'all. Plus 3 over here. Thank you, thank you. Okay, any other questions, comments? All right, so we are going to add to yesterday's. Y'all have 20 minutes to work on it and ask questions. Add these to what we did yesterday.
I